Welcome to all. In today's class, we are going to see what are all the types of errors which occur during the process of measurements. It's quite natural that error may occur during the process of measurement by a person. So, if you want to eliminate or reduce the error, we have to know what are the sources or the cause for the error. First, we will see what are the sources which are responsible for the errors. Then we will see what are all the types of errors. First, we will see what are all the sources of errors. So, during the process of measurement, the error occurs. So, if you know the sources of that errors, we can eliminate or reduce them. There are various sources of errors. The first one is the error may occur due to the faulty design of the instrument. Due to the faulty design of the instrument, there will be a serious error occur during the measurement process. Second one, due to insufficient knowledge of the quantity to be measured, the error occurs. So, if a person who is measuring the quantity which is to be measured does not have an sufficient knowledge about the quantity which is to be measured, a serious error will occur. The third one is, for some instruments, frequent maintenance is necessary, is needed. If it is not done, error will occur. So, some instruments require frequent maintenance so that error will not occur in that instrument. If it is not frequently maintained, then error will occur. It is a cause for error. Fourth one, if there is sudden change in quantity under measurement, it will cause error. If there is sudden change in the quantity which we are measuring, there will be the chance of occurring error. Next one, unskilled operator. So, if an unskilled operator is using an instrument for measuring the quantity, then error will occur. Sixth one, because of loading effect, also error will occur. Loading effect is nothing but the improper way of using the instrument. The improper way of using the instrument is called as loading effect. Because of this loading effect, error will occur in the instrument during measurement. Next one, due to the effect of environmental conditions like temperature, pressure, stray capacitance, etc., the error will occur. So, these are all the various sources of error which will cause error in the instrument while taking measurement. So, first one is the faulty design of the instrument, which will cause a serious error while taking measurement, and due to insufficient knowledge in handling the instrument which is used for measuring the quantity to be measured, error will occur. And for some instruments, frequent maintenance is needed. If the frequent maintenance is not done, then error will occur. And also, if there is sudden change in the quantity under measurement, error will occur. And if an unskilled operator is using an instrument for measuring the unknown quantity, error will occur. And also, the loading effect causes error. The loading effect is nothing but the improper way of using the instrument. If instrument is used in an improper way, it will cause error. Next, last one is the effect of environmental conditions. That is, external environmental conditions like temperature, pressure, stray capacitance, etc. will cause error during the process of measurement. Next, we will see what are the types of errors. So, the errors are generally classified into three types. One is gross error, second one systematic error, and third one random error. First, we will see what is gross error. So, the gross error occurs due to carelessness or lack of experience of human being during measurement. Due to carelessness or the lack of experience in taking the readings by a person will causes gross error. So, this also includes human mistakes like in taking readings and calculating the result. So, if a person or a human being who takes the reading and calculates the results will cause some mistakes, will make some mistakes, so that mistake causes gross error. And this gross error also occurs due to incorrect adjustments of the instrument. Due to incorrect adjustment of the instrument also the gross error occurs. So, generally this gross error is called as personal errors. So, this gross errors cannot be eliminated because it depends on the human mistakes. So, this can be reduced by some ways so that we can get accurate readings without this gross errors. So, this gross errors can be avoided by, it can be eliminated by taking care while taking readings and calculating the results. So, we have to take care while taking the readings and calculating the results so that we can eliminate this gross error. Second, we can eliminate the gross error by taking more number of readings by different person. So, the readings taken by a person varies from person to person. So, by taking more number of readings by different persons, this gross error can be eliminated. The second type of error is systematic error. The systematic error occurs due to the shortcomings of the instruments and the characteristics of material used for that instrument. So, mainly the systematic error occurs due to the shortcomings of the instruments and the characteristics of the material which is used in the instruments, such as defective or worn parts which are used in the design of that instrument. Second one is aging effect of the materials or parts inside the instrument, and also due to environmental effects, etc. So, these are the various causes for the systematic error. So, based on this, the systematic error is further classified into three types. The first systematic error is, this error occurs mainly due to three effects. So, first one is called as instrumental errors. Systematic error is classified into three types. The first one is instrumental errors. So, mainly this instrumental errors occurs because of three reasons. First one is due to shortcomings of the instrument. What is the reason for the shortcoming of this instrument? This shortcoming of the instrument occurs because of the mechanical structure of the instrument. Because of the mechanical structure of the instrument, this shortcoming of the instrument occurs. Let us see the example for the shortcoming of this instrument. Example, friction effect which occurs in the bearings of various moving parts in the instrument causes this shortcomings of the instrument, which leads to this instrumental errors. The friction occurring in the bearings causes this instrumental error, and also the irregular spring tensions causes instrumental error, and also the stretching of the spring causes instrumental error because of the aging effect, and also the gear backlash which we have seen earlier will also cause the instrumental error, and also the variation in the air gap between the magnets and the moving parts also will cause instrumental error. So these are the various examples for the instrumental errors, that is the friction occurring in the bearings of the various moving parts, and the irregular spring tension and the stretching of the spring due to aging effect, and the backlash and the variation in the air gap will causes this instrumental error. How we can avoid this instrumental error? So this instrumental error can be avoided by, first one, we have to select proper instrument and planning proper procedure for measurement. So for measurement we have to select a proper instrument and a proper procedure must be followed for taking the measurement, so that we can avoid this instrumental errors. Second one, we have to recognize the effect of these errors and apply the proper correction factors in order to avoid this errors. So we have to recognize the effect of errors occurring due to these reasons, and we have to apply the proper correction factors in order to eliminate these errors. Third one is we have to use a well calibrated meters for measurement. So the meter must be calibrated against a standard meter for measurement. So with that calibrated meter, these errors can be eliminated. So the instrumental errors can be eliminated by choosing proper instrument and proper procedure for measurement, and we have to use a calibrated meter for that measurement. And if error occurs, we have to recognize that effect of that error, and we have to apply the correction factors in order to correct that error. The second reason for the instrumental error is the misuse of this instrument. First one is the shortcoming of the instrument, second one is the misuse of the instrument. What do you mean by the misuse of this instrument? If a good instrument is used in an abnormal way, gives misleading result. So if a good instrument, a well calibrated instrument, but it is used in an abnormal way, will give a misleading results. These are the causes for the instrumental errors. So example for this misuse of this instrument is, first one is poor initial adjustments in the instrument. We have to make correct initial adjustments. The poor initial adjustments of a good instrument is the misuse of that instrument, which causes errors. That is, error is called as instrumental errors. Second cause is the improper zero setting of the instrument is the cause of misuse of the instrument. And third one, using leads of high resistance will also be the reason for the misuse of the instrument. So this misuse of the instrument occurs because of poor initial adjustments, improper zero setting, using leads of high resistance. These are the causes for instrumental errors. So this misuse of the instrument will not cause any permanent damage to the instrument, but causes instrumental error. And third reason for the instrumental error is the loading effect. So loading effect is nothing but the improper way of using the instrument, is called as loading effect. Example for loading effect is, if you are having a well calibrated voltmeter, it is connected across the 2 points of a high resistance circuit. So it is connected across 2 points of a high resistance circuit. So the voltmeter reads, and it is connected across the 2 points of the high resistance circuit. The voltmeter will read a value, but the accurate reading of that voltmeter will be in the case if the same calibrated voltmeter is connected in low resistance circuit. So if well calibrated voltmeter connected across the 2 points of high resistance circuit will cause error. If the same meter is connected across low resistance circuit, will give accurate readings. So, the proper way of using the instrument in a circuit will eliminate this error due to loading effect. So, this can be avoided by using the instrument intelligently and correctly. So, by correctly using the instrument in a circuit, we can eliminate the error occurring due to loading effect. The second type of systematic error is the environmental error. So, this environmental error occurs due to the external environmental conditions while during measurement. So, this environmental error occurs due to external environmental conditions during measurement. So, what are the factors causing this environmental errors? There are various factors which causes environmental errors. The first one is the temperature changes. Due to the change in temperature, the environmental error occurs. Then pressure changes due to stray capacitance. Then due to effect of external fields and also due to the aging of the instrument, etc. So, these are the factors which causes the environmental errors. How can you eliminate or reduce this environmental error? So, this environmental error can be reduced by using proper correction factors and using the information supplied by the manufacturer. Using the information provided by the manufacturer, we have to use the proper instrument in proper environmental conditions. Second one, you have to arrange surrounding conditions or make the surrounding conditions of the instrument as constant, which includes like air conditioning in order to reduce the temperature of that environment, so that instrument will not get affected by the temperature changes, or using a temperature control methods in order to reduce the temperature. So, the various methods which makes the surrounding conditions constant like air conditioning, temperature control methods can be used in order to eliminate this environmental error. The third one is how to reduce the effect of external dust, humidity on the components of the instrument, so that it will not cause environmental errors. How you can eliminate this is by proper shielding. We can eliminate the effect of dust and humidity on the components of that instrument. And the fourth one is the effect of external fields has to be prevented by using proper magnetic or electrostatic shields for the instrument. By using proper magnetic or electrostatic shields which covers the instrument, the effect of external fields can be eliminated. And the fifth one is using the instrument which is immune to environmental effects, or else we can use the instruments which are immune to the environmental effects like temperature, pressure and external fields. For measurement, we can eliminate this environmental errors. And the third type of systematic error is observational error. So, from this we can say that the observational error occurs or it will be introduced by the observer who is taking the readings. So, the observer who is measuring the unknown quantity is responsible for this observational error. So, example for observation error is a well known error called parallax error, which occurs during the measurement. That is, and also while taking readings, proper scale must be used, and the habit of that observer while taking readings must be changed in order to reduce this error due to the observer. So, this observational error can be eliminated by using instrument, mirrors and knife edged pointers in order to remove this parallax error. The second one, now there are many digital instruments available. So, this can be reduced by using instruments with digital displays. So, the instruments with digital displays can be used for reducing this observational error. So, first we can eliminate this observational error by using the instruments with mirrors and knife edged pointers, so that we can remove the parallax error by taking the readings, so that the pointer image coincides with the mirror while taking the reading, so that we can eliminate this parallax error. Else nowadays we are having many digital instruments, so we can use instruments with digital displays for taking the reading, so that we can eliminate this observational errors. And the third type of error is called random. So, here we have seen two types of error. One is gross error, second one is systematic error. And the systematic error is further classified into three types: environmental error, observational error and instrumental error. And the third type of error is called random error. So, the reason for this random error is unknown, because this random error occurs due to the accumulation of large number of small effects. Due to the accumulation of small errors, this random error occurs. So, there is no particular reason for this random errors. So, these errors are taken into great concern if high degree of accuracy is required for taking the measurement. So, the causes for this random errors may be the accumulation of many small errors like friction, backlash, hysteresis, then maybe parallax error, etc. So, these are all the causes for random errors. This random error occurs because of the accumulation of all the small effects which causes error, and this random error are of great concern only if high degree of accuracy is required, otherwise it can be eliminated. How can we reduce this random error? So, the only way to reduce this random error is by increasing the number of observations made while taking the readings. During measurement, we have to increase the number of observations made by the observer in order to reduce this type of errors. And also we can use statistical methods to obtain best approximation of the readings. So, we can increase the number of observations so that we can reduce the random error, and also we can use many statistical methods to obtain the approximation of the readings so that the effect of error can be reduced. Next, we are going to see what is standard and what are all the types of standards used for measurement. So, we can define standard as a known, accurate measure of a physical quantity. So, standard means a known accurate measure of a physical quantity is called as standards. So, all the instruments are calibrated at the time of manufacture against a particular standard. So, all the standards of the physical quantities are preserved at International Bureau of Weights and Measures at Sevres near Paris. So, standards for all the physical quantities are preserved at International Bureau of Weights and Measures near Paris. So, which is used as a standard for calibrating all the instruments. Next we will see what are all the types of standards. The first type of standard is international standard. Second one is primary standards. Third one is secondary standards. And the fourth one is working standard. There are 4 types of standards. One is international standard, primary standard, secondary standard and working standard. First we will see what is international standard. So, this international standard or the international agreement, so these standards are maintained at International Bureau of Weights and Measures near Paris. So, it is maintained at International Bureau of Weights and Measures near Paris. So, these are defined as the international agreement and the standards are maintained at International Bureau of Weights and Measures near Paris, and these international standards are periodically evaluated against the absolute units and the measurements in terms of this physical units. So, these international standards are not available outside for the ordinary uses for calibration purpose. So, these standards are not available outside the International Standard Laboratory for calibration purpose. These are maintained at International Bureau of Weights and Measures near Paris, and frequently it is evaluated against the absolute standards. So, the absolute standards are a higher standard than international standard. The second type of standard is primary standards. So, the primary standard or the higher accurate standards which can be used as reference standards. So, these primary standards are of highly accurate and it can be used as a reference standards for calibration purpose. So, these primary standards are nothing but the photocopies of this international standards or the photocopies of this physical quantities which are available in the international standard laboratories, which is maintained at International Bureau of Weights and Measures near Paris. So, this photocopies of this international standard are called as primary standards, and this are maintained at national standard laboratories in different countries. So, this primary standards, which are the photocopies of this international standards, are maintained at national standard labs in different countries. This primary standard are also not available outside the national laboratories. It is not available outside the national labs for calibration purpose. So, the main function of this primary standard is the verification and the calibration of the secondary standard. Next, we will see what is secondary standard. So, as we know that the international standard and the primary standard are not available outside the labs to protect the highly accurate primary standards and the international standards, the secondary standards have been formed and it is maintained for the calibration of the instruments in the industries. So, these secondary standards are designed and calibrated from primary standards. Since the primary standards are not available outside the national labs for calibration purpose, the secondary standard have been designed and it will be calibrated from the primary standards. So, these are used by the measurement and calibration labs in the industries and it is maintained by a particular industry to which they belong. So, these standards will be used by the calibration labs in industries and are maintained by particular industry to which they belong. So, the particular industry will maintain this secondary standard in their calibration labs for calibrating their manufactured instruments. So, this secondary standards will be often frequently sent to this primary standard to the national labs where the primary standard is maintained and will be calibrated. So, this secondary standards sent to the primary, that is the national labs where the primary standards are maintained and it will be calibrated so that they can use in their calibration labs. So, what the primary standard will do that the primary standard will send the calibrated instrument, that is secondary standard, with a certification that it has been calibrated with the primary standard. So, the certification with that secondary standard indicates the certification provided by the national labs indicate the measuring accuracy of secondary standards. So, the certificate indicates the accuracy of the secondary standards which is used in the calibration labs in the industries. So, the industries will use that instrument which is calibrated with the primary instrument for their manufacturing purpose. Fourth one is the working standards. So, the working standards are nothing but these are the normal standards used by the workers and technicians who carry out the measurement. So, this working standards will be used by the workers and technicians who carry out the measurements. So, the standard or the accuracy of this working standard will be one order lower compared to the primary standard or the secondary standard. So, the accuracy of this working standard will be one order lower than the secondary standard. The example for this working standard is, example, there is a resistor manufacturing company. The industry is manufacturing resistors. So, the industry manufacturing resistors, there is a resistor manufacturing industry. So, the industry is manufacturing resistors. So, they have to calibrate their manufactured resistor with a well calibrated standard resistor. So, what they will do this in their calibration lab, they will maintain a standard resistor which is calibrated with the secondary standard in their calibration lab. So, the standard resistor maintained by this resistor manufacturing industry will be calibrated with the secondary standard. So, this standard resistor will be used in their calibration lab. So, what they will do this, they will calibrate this standard resistor will be used for calibration of resistors manufactured by the industry. So, the industry will calibrate all the resistors manufactured by them with the standard resistor, so that they will check whether the resistor manufactured are within the accuracy limits. This standard resistor will be frequently calibrated with the secondary standard. So, in this class we have seen what are all the types of errors and standards used in the measuring instrument. Thank you.